This is video 3 on theory of production. In this video, I will show you how we can derive the values of total product, marginal product, and average product. So for that, first just recall that total product. So when I derive these, I'm still in the short run, which means only one variable factor, which I am assuming to be labor. Okay, therefore we are looking at total product of labor, marginal product of labor, and average product of labor. Okay, total product of labor, okay, or QL, okay, is a function of L. Okay, and it is a positive function. That means as L increases, QL increases. All right, so that is number one. Number two, marginal product of labor is defined as the change in the quantity of output due to a unit change in the quantity of labor. Okay, this we know to be positive, all right, and also as L increases, MPL decreases. So diminishing marginal returns to labor. And the third variable that we're going to derive is known as average product of labor, which is defined as total product of labor divided by the units of labor. So it is basically output per unit of labor. Okay, and we will see that this number is also greater than 0, and as L increases, average product of labor decreases. Okay, just an extra bit of information. APL is easier to measure, and so in growth theories, for instance, when we try to explain economic growth, a very popular measure is that of productivity, and productivity is simply the average productivity of labor. So it is a measure. So this term productivity is often used in macroeconomics when looking at long-run growth theories of countries. This productivity is basically the average product of labor. Okay, now let's go back to this empty table and try to fill it up. Okay, so we will start with some numbers, assuming some numbers. In the first column, we measure the quantity of labor. In the second column, we have total product of labor, Q. Here we have MPL, so for which you would need to divide the change in quantity of output by the change in quantity of labor. And in the fourth column, we have average product of labor, which is total product divided by the total number of labor that is used. Okay, so let's say, start with 0, 1, 2, 3, 4. Okay, let's say 5. All right, so these are the quantities of output. Now, since output is a function of labor, if there is no labor, right, 0 labor, then we get 0 output. Okay, and we cannot measure these. Okay, now suppose the farm adds 1 unit of labor. Okay, so this 1 unit of labor produces 10 units of output. All right, so now what is the marginal product of this 1 unit of labor? That is, by how much does output go up when labor changes by 1 unit? So basically delta Q is the output changes by 10, right? And our delta L is 1, right? That is the increase in labor, that is 1. Okay, so MPL then is delta Q divided by delta L, which is 10 over 1 or 10. Okay, so note that in this particular example, right, L is always increasing by 1, which means the denominator of MPL will always be equal to 1 in this particular example. And therefore, it is sufficient to simply look at the change in Q because delta L will always be 1. Okay, so second unit produces, after adding the second unit of labor, the farm produces a total of 18 units of output. Let me let's put in some numbers for this one: 24 and then 29. Okay, and then let's say this is 30. Okay, and so let us fill out these other two columns. First, let us look at the marginal product of labor. So when the second unit of labor is added, that is, number of labor increases from 1 to 2, so delta L is again 1, then what is the change in output? So note that output now increases from 10 to 18. That means marginal product of labor for the second unit of labor is 8. For the third unit, it's 6, right? 24 minus 18. So delta Q is 6 and delta L is again 1. 3 minus 2 is 1. Then from the third to the fourth, when the fourth unit of worker or labor is added, output increases from 24 to 29, which means it increases by 5 units. And then when labor is increased from 4 to 5, the fifth unit is added. That fifth unit adds 1 unit of output. Okay, so if you look at marginal product, right, note the relation between L and MPL and see if this is satisfied. We claimed that as L increases, MPL decreases. This is the law of diminishing marginal returns to labor. So this is, do we see that in the table? As L increases, right, MPL decreases. Do observe that. Now let's look at APL. APL is total output divided by total units of labor. So in the first case, total output is 10, right? And total units of labor is 1. Therefore, APL is 10 by 1 or 10. Okay. For the second unit, output is 18 and total number of labor is just 2. So APL is 9. Okay. For the third, so 3 units added, output is 24. So APL is 8. 24 by 3. Okay. So 4 units of labor is producing 29 units of output. So 29 by 4, which is 7.25. Okay. And 5 units of labor produces 30 units of output. So 30 by 5, that is 6. So note how APL is behaving. APL is also decreasing, right? So it is decreasing as L is increasing. So the same thing. Okay. Now this is so this happens for most of the production process. However, we will show that there is some part of the production, okay, where MPL and APL actually go up as L increases, but only up to a certain point. They reach a maximum and then they both start to decrease. Okay, and why am I pointing out only this part of the production functions when they are decreasing? Because when we will do the next chapter on cost, you will see that these are the portions which are more relevant. Okay, so in this video we saw how to mathematically calculate MPL and APL, right? In the next video we are going to draw the graphs, how we can derive MPL and APL graphically from the total product curve.